We're going to look at some practice problems with the interpretation of the definite integral. So I'm glad you're here. If this is the first time you're seeing my face, please make sure it's not the last by clicking that like and subscribe button. And that way you'll get a notification every time a new video is posted. So let's dive right in. We're being told that there's 120 pounds of sand in a conical tank. Sand's being added at the rate of S of t. And sand from the tank is used at a rate of R of t. And we know the tank can hold a maximum of 200 pounds of sand. So let's find the value of the integral from 0 to 4. Then what does this represent? So if we use the integral from 0 to 4 of S of t, I'm going to switch us over to Desmos so we can type in this integral. If you are using the TI-84, no worries. You can do the same calculations on the TI-84. You'll just need to use the second trace menu. Sorry, I had to think about what that menu was today. Oops, and we need a +2 in there. There we go. And by the way, just to get that integral in Desmos, I just typed INT. That's how I get that one. 21.173. Now, this is the rate is pounds per hour. So if we do the antiderivative of that, that's just going to be pounds. And this is S. So S of t, remember, is sand being added. This is the total. Sand added from t equals 0 hours to t equals 4 hours. Okay, now look at the next one. We're being asked to find the integral of R of t. So we're going from 1 to 3 of R of t, which is 5 sine squared of t plus 3 square root of t. And again, I'm going to switch this to Desmos so we can type that one in. INT, got my bounds. Going to type in. Just got to be real careful with your parentheses when you're working in Desmos. And by the way, I use square root. I just type SQRT. And that gave me 14.878 pounds. And then this is the total, it's R of t. So remember, that's the sand being used. So this is the total sand used from t equals 0. Oh, sorry, t equals 1 hour to t equals 3 hours. Okay, now we want to find the value of the integral with a 1/4 in front of it from 0 to 4. So we actually found the integral from 0 to 4. Now we're going to multiply it by 1/4. So we're going to use our answer. And this becomes, let's do a little calculation here. It gives me 5.293 pounds. And so notice what we found here. We found the total amount coming out between 0 and 4 hours, and then we divided by 4. We just found the average there, okay? This is the average value of sand, and it's S of t, so it's sand added per hour. And maybe I shouldn't do it per hour because that sounds a lot like a rate. Maybe in 1 hour, we could say that, but it is the average of the amount that went into the tank in 1 hour, okay? Now, 4 says, write a function a of t containing an integral expression that that expresses the amount of sand in the tank at any time. Okay, so think about this. I've got to have a beginning amount. So we were told we started with 120. Then I've got to calculate how much went into the tank. So that's our integral from 0 to t. Notice I'm just going to use a time of, that's going to be s of t. So it's 2e to the sine squared of t plus 2 dt. And then I'm going to subtract the amount that's being used. Again, integral from 0 to t. And the reason I'm using the bound of t is because I don't know when that ends. Okay, I just want to know at some value of t. And this is of r of t. And that's it. So now number 5 says, okay, now that you found that, go find out how much sand was in the tank when t is 7. So we're going to plug in 7 for t. And we'll have to rely on Desmos for these integrals, but that's okay. I'm going to show our Desmos screen. And friends, we already have these values, these equations in here, really nice. So I'm going to just change the bounds. That's my that's my S integral. So that's 37.721. Oops, and I need a minus there. And then this is my R. So I'm going to do 0 to 7 here. And that's my 53.302. And then I get to add and subtract. So let me switch our view back. We'll type those in. 120 plus 37.721 minus 53.302. And that gives me 104.419. And this is in pounds. Okay, now look at number 6. At time t equals 7, sand is not used anymore. Sand is, however, added to the tank until it is full. So at time t equals 7, R of t goes away, right? Because we're not bringing out any more sand. If K represents the value of t at which the tank hits a maximum capacity, remember that maximum capacity was 200, write but do not solve an equation with an integral expression to find how many hours it will take before the tank is completely full. Okay, so let's first account for the amount of sand in the tank at 7. So we're going to use that 104.419. Okay, now we quit using R of t because we're not having any sand come out. Now I want to know, when is this going to equal 200? And now I need the change from 7 to some value k of the amount of sand going in, and that's our S of t. Now, thank goodness they didn't ask us to solve that one, right? Oh, that's a good one. Friends, it's all about the interpretation on these, though. Okay. Now, I have a few AP problems that I think are going to be good resources to practice the same kind. We get lots of examples, and I'm going to link their solutions below, but I want to definitely show them to you. That way you get a feel for which ones you want to be able to point out. It's going to be 2005, number 2, 2005, number 3, 2002, number 2, and the 2000 exam, number 4. All of these are excellent AP problems over the same concept, and I'm going to link their solutions in the description here for you so that you can access those. Friends, thanks so much for watching. I enjoyed it. As always, if you have questions or comments, please leave them in the comments below. I would love the opportunity to help further with more videos or more explanations. I'm on a mission to help students feel comfortable and confident in their math classroom. So I'd love the opportunity to work with you. Bye for now.